What's up, guys? Today we're going to solve this question, valid arrangement of pairs. So the question is kind of pretty much straightforward, and you must have already guessed the answer of it, how and how to do it. So let's say we have this pair. Here it is, right at this place. So we want to arrange into this manner so that once we start at 11, we are sure that the next of 9 is another 9 and it is connected like this. So you must be thinking you must have a quotient simply, let's say, somehow we get up at this place. So we're gonna pick this value and we're gonna compare among all of these three values whose starting values start with 9. So we got this. So we are sure that this one is the first position. Then after that, this is the next of it, which is, let's say if it is I, then it is I plus 1. So that's pretty much it. Then you must be thinking, once we get to this place, we're going to pick the value of this end value, f4, and we're going to check among these two. And we got found out that this is the thing. This is the node which we're looking for. So we're going to connect this. Then after that, in the end, this is remaining since this 5 is connected to this 5. So you must be thinking that's the way. I mean, yeah, it is. I mean, the over complexities comes out to be n square, and the n which we have right at this place is 10 raised to the 5, so it's obviously going to be 10 raised to the power 10. So it's kind of solution which is going to give us the error of tile limit exceed. So can we do better? I mean, is there any way? Yes, there is a way. If you look clearly, I mean, by using this values we can draw a graph. I mean, literally. So I mean, let me just show you, demonstrate with the drawing. So let's say I'm at fifth node. So if I see fifth one connect the first one, so 5 connects 1. Then after that, what I can see, 1 connects nothing. So this must be the end node. Then after that, what I can see, 4 connects 5. So let's say 4 is right at this place and it's connect to 5. Then after that, what I can see, after that I can see that 9 connects 4. So basically I'm going to draw this 9, this will connect the 4, and in the end 11 connects the 9. So you must have guessed this thing right. As you can see, it's a over a graph. And what if we just get to know the starting position of it? We can simply iterate over it and just gonna create this kind of pair somehow, and we can get an answer. But yeah, that's the question, but there is a concept behind it. The graph which I've just formed is basically nothing but a Euler graph. Just let me just write it for you guys. So basically, in our question, we can have two types of Euler graphs. The first graph is Euler path, and the second is circuit. So let me just show you the example. So path basically means, let's say I have graph like this, and let's say this is connected to this is connected to this. So I'm able to travel all the edges, and or I'm able to connect all the nodes. And let's say I have a graph like this, in which it is connected this, but this one point this, and this one point this. So although I'm able to travel this too, but I will never be able to travel this part of the node since it is pointing in this direction. So this is not an Euler path. So this one is the Euler path. Euler path is that path, I mean, in which we are able to cover up all of the nodes by using without lifting the pen. And on the other side, we have a circuit. So in circuit, it is nothing but if I try to create a loop into it, the starting position and the ending position will become the same. And also we are able to travel all over the places, all over the graph. So without lifting the pen. So that's the Euler graph. That's pretty much it. I mean, you don't need to go in depth, but in our question, whatever the graph you're going to draw, any of these examples, we are always going to tackle with this kind of graph, the Euler graph. So that must be in mind. Since you got to know this, now how can we solve this question? So it's pretty straightforward and kind of easy. So let me just show you the approach. So first of all, I'm going to create a map in which I'm going to store these nodes, the 5, the 1, the 4, the 9, and the 11. So after that, how gonna you gonna guys guess that which is the end node and which is the starting node? So I'm just gonna draw a simple demonstration of it. So let's say O is outer degree, which means that how many arrows or you can say edges are coming out of that node, and I is the inner degree. So which tells us how many nodes are ending inserting towards this node. So this is in degree and this is outer degree. So let me calculate for 5. So 5, it is 1 1. As you can see, it has having in and out at both at the same times. Then after that 1. In 1, what they can see is that it only got 1 in degree and no out degree. So out degree is 0 and degree is 1. Then after that in 4, it is 1 1, and in the 9 it is also same, it is 1 1 since it's coming in the middle. Then in the 11, as I can observe, guys, right at this place, the 11 have only 1 out degree and no in degree. So and that's the spatial power of this graph. I mean, that's the spatial power of this Euler graph. Once we can only find, I mean, we get to know what is starting position just by looking at this value. If we try to do a subtraction of outer degree minus inner degree, and the value comes out to be 1, there is a formula for this. If comes out to be 1, then in a Euler path, this is sure that this is our starting position. But what if we try to pick this case 2, in which 1 connects to 3, 3 connects to 2, 2 connects to 1. So basically means it's a cycle. In this, 1 connects to 2, and 2 connects to 3, and 3 connects to 1. So it's a cycle. So as you can observe that there is no starting position. So how can we deal this thing? So in this case, we can pick any of this and we can reach at any location, and this is basically the Euler circuit. So that's all. That's the whole thing which you need to know about the quotient. And yeah, that's the whole concept of in order degree and inner degree. That's how we can find the starting node. Then after that, what can we do? How to transverse? So transfer is kind of easy. Let me tell you why. So let's say I'm just gonna erase this thing up so make some more space to write this content. So let's say if I start at this 11, if I start at this 11, I'm gonna maintain a stack. I will like app stack. I have at this 11. I put it inside this. Then I'm going to towards this adjacent value. So it's kind of adjacent list. If I try to draw adjacent list could like kind of look like this. 11 connected to 9 and 9 connected to 4, kind of like this. So if I try to do this, if I try to start with 11, I got another value 9, which is also going to put in the stack. Once I do this, I can going to travel to the fourth of it. I'm just keep on adding this value to the stack, which is connected to this. 4 connected to 5, then 5 connected to 1. In the same way, in the end, we gonna fill up our stack, and after that we're gonna pop out all the values, so it will be in reverse order: 5, 4 and 9 and 11. Or as you can see, just by doing this kind of stack operation, we can observe that our answer is exactly reverse of it. I mean, if I try to pick this value and reverse it, and that's how we get our answer. So let me just code this thing up for you guys. So it's kind of easy question if you know the basic concept. So let's say first of all I'm going to create an agency list. So agency list is kind of default dictionary of list, since we have an integer value, and integer value consists of list. So let's say if there is, I mean, I'm just gonna tell you why we are using default dictionary. Then we have in order. In order is basically, I mean, in degree. Basically, it is also a default dictionary of integer. Then we got uh, out degree. Out degree is nothing but a default dictionary of integer. Then after that we got nodes. So nodes is basically a collection of all type nodes which we have present in our graph. So first of all, I'm gonna fill up this thing. So I'm gonna iterate over by destructuring it x and y in pairs. After doing this, what we can simply do, we got agency list, we're going to do this x, and then we're going to append it to the y. So you must be thinking, let's say this dictionary is comes out to be none. I mean, that's why we have put it this default dictionary. Or if it comes out to be none, it's going to create a list or empty list. So this will handle the situation. Instead, we must have using this thing curly braces. So that's why we use the default dictionary right at this place. Then after that, what we're gonna do, we're gonna simply do in degree, in degree, we're gonna increment this in degree of x. I mean, not x. It's obviously first of all, the out degree is coming out of the x, since I've just shown you. Like let's say, 5 is moving outward. So this way, that's why its out degree will increase, and this in degree, y's in degree will increase. So x degree will plus 1. Then after that, in degree of y will increase by plus 1. In the end, we're gonna keep track of the nodes. So we're gonna add this x node as well. We're going to append and add this y node. Then after that, what we're going to do, we need to find the starting position. So there is two cases. I mean, it could be a Euler path or it could be a Euler circuit. So let's just assume that it is a Euler path. So we're gonna iterate over each nodes in the node set, and I'm gonna check if the the out degree of this node subtracted with the in degree of this node, and if it comes out to be 1, then simply we found out our initial position. So this is going to be our starting node. So starting node is none, and this is going to be the starting node. Starting node is gonna be node this, and we're gonna break out the loop. If we are unable to find, let's say we are unable to find the starting node, which means that it is a circular, what do we say, circuit, Euler circuit. So we can pick any of these. So if s node is still none, so if that's the case, we're simply going to assign this s node the first value of pairs, which we have pairs of 0 comma 0. Since we got this, we can just move on. We say we are finally able to find the starting position. Now things are kind of easy. Then after that, what we can do, we gonna iterate over each of the values. So I mean, how can we do this? So I mean, I will like find Euler path. Euler path function. I'm gonna create this function, and I'm gonna pass the starting node. And for this, I'm gonna create a variable which is kind of array of path, which is going to just keep track of the path of my Euler path. Yeah, that's it. Then I'm gonna create this nested function Euler path, and in this path I'm gonna pass this current node, and I'm gonna iterate over the agency values, which is basically the agency list of the neighbor nodes of this current. And I'll be like, next node of this is gonna be this agency of this current. It will pop out this value from the list so that we'll get the end value. And we're gonna create a stack by using a recursion Euler path, and it's going to put this next node into it. Then after that, I'm gonna do path dot append. So and after that, I'm gonna append this thing. So basically, it is going to create this thing. It is going to create this recursion stack, and it will be in reverse order, like I've shown you. If I try to pop it out, it will be a list kind of like this. So I need to reverse this thing. So I will like path dot reverse. So you must be thinking that's the answer. No, the answer is not, still not. We still don't have the answer yet. And I mean, path will be reversed after we call the function, not before. So path will be reversed after it. Once we done that, we're gonna create a variable result. In the result, we're going to pass this in this pair in the list of pairs instead of individual integer. So here we go again. So in simple terms, the what do we say? We're gonna iterate over I in range by leaving the first value, since we are going to include it by using I minus 1. So of path, and then simply I will like result dot append what? Append the list of path, the previous one which it have, and the current one which it is currently right at that place. Then after that I'm going to return my result, and that's it. That's the whole code. Let's just run this thing up, and hopefully, I mean, okay, I mean there is a spelling mistake, little typo. I mean default dictionary. Hopefully this time it will run the code, and that's how we solve this question. Okay, bro, where the hell we got the error? Let me just check. Uh, so okay, I think I called this thing in instead of. I mean I should have called is, not in. It's not inside. It's kind of comparing these two things. Yeah, that's it. That's pretty much it, and that's how we solve this thing. Uh, we're gonna first of all create the agency list, then gonna find this initial position, and we're gonna transverse it, and that's how we do it.